In this video, we are going to be talking about polynomial inequalities. So instead of where it equals 0, we're going to talk about being less than or equal to, greater than or equal to. So all of these problems are going to be quadratic functions. If I FOILed this x minus 3 and x plus 4 together, I would actually get an x squared graph. Okay, but I don't want to do that because that's taking what we're going to be doing backwards. I want to see the factors so that I can get the zeros. So I have x minus 3, I'll set that equal to 0. X plus 4, I'll set that equal to 0. And then solve them for x. So if I add the 3's to both sides here, I have x equals 3. The other one, I'll subtract the 4 to get x equals negative 4. So here's what I need to know. I need to know where the zeros are of the function, which is what we just did. Those are going to be your x-intercepts. So there's going to be an x-intercept at positive 3 and another x-intercept at negative 4. So I know that this is a parabola because, like I said, if we would have multiplied those x's together, we're going to have an x squared graph. Now I need to know if that x squared is going to be positive or negative, because remember, a positive x squared opens up and a negative x squared opens down. Well, if I've got positive x times positive x, that one's going to be a positive x squared. That's what I need to know. I need to know where the x-intercepts are and whether or not it opens up or down. Now, this question is wanting to know on what interval is this less than 0. Well, 0 is your x-axis. So the part that is under the 0 is the part that's below the x-axis, which means starting at negative 4, it goes below, and it stays below until it gets to positive 3. Now, these here are not included in what I'm talking about because we don't say less than or equal to 0. We just want to know the parts that are below 0, which means this interval will get a parenthesis. All right, on this next one, we have x squared minus 14x plus 33, and I want to know where that is greater than 0. So on this one, it's not in its factored form like the last one. So I'm going to start off by putting this in its factored form. I will need the terms here to multiply to equal x squared. So I'm going to need an x times an x. Now, the terms that go at the end have to do two things. They have to multiply to positive 33 and at the same time add to negative 14. The numbers that are going to do that are a negative 11 and a negative 3. Because a negative times a negative does give you that positive, and negative 11 plus negative 3 gives you that negative 14. Now, I can set them equal to 0 and solve them for x. So on the first one, I'll add the 11 to both sides. So I'll get x equals 11. And on the other one, I'll add the 3 to both sides. So I get x equals 3. So those are going to be your x-intercepts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 1 and 11. Oops. So 1 and 11. Oh, shoot. Hang on. So there's 1 at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm making that circle open because I don't want to include the 11 because it's not greater than or equal to, it's just greater than. There's another x-intercept at positive 3. Your x squared is a positive 1, which means, again, this parabola opens up. Now, this one wants to know where it is above 0, greater than 0. Remember, your x-axis is 0, so this interval is above it. Then it drops below for a little while, and then it comes back above it on the other side. So my intervals, my first interval would be from negative infinity until it gets to 3. Then in union with, because it stays below for a little while until it gets to 11. And then it stays above forever to positive infinity. Now, the reason I have our quad calculator over here is because you'll notice from at the very beginning of this problem, I could use that to go ahead and find my zeros because it's quadratic, because it's x squared. A is in front of x squared, so it's a 1. Your b is in front of x, so it's negative 14. C is your constant, which is positive 33. When you calculate, look what you get. It gives you positive 11 and positive 3, which is what you got as your zeros. So your quad calculator can help you in this section. All right, looking at another example. I've got x squared plus 7x minus 12 is greater than or equal to x minus 5. And I would like to use my quad calculator, but before I do that, I have to have all the terms on one side with a 0 on the other. So I'm going to subtract x from both sides and add 5 to both sides, because that will make my right side be 0. Let's see what it does to the left. I've got x squared plus 6x minus 7 equals 0. So now I can go to my quad calculator and put in my a is 1, my b is 6, and my c is negative 7. And then calculate to see what my zeros are. So you'll notice it gave me positive 1 and negative 7 as my zeros. Those are your x-intercepts. So there's an x-intercept at positive 1 and one at negative 7. Again, my x squared is positive, so I am opening up again. And this one wants to know where it's greater than or equal to 0. So greater than is above the x-axis. So I am talking about this interval until it gets to negative 7, then it drops below until it gets to the other side. So here's my two intervals. The first one on the left side is negative infinity until it gets to that negative 7. But this negative 7 has a bracket around it because the equal to means you want to include that negative 7 in your interval. Then it drops below the x-axis until it gets to positive 1. So we're going to have in union with positive 1, again with the bracket, to infinity. All right, next example, I'm going to do the same thing. It's quad, so I want to find my zeros using my quad calculator. And I've got to subtract the 16 from both sides. So now I have x squared minus 16 is greater than or equal to 0. Be careful when you choose your A, B, and C. A is in front of x squared, so it is just a 1. B is in front of x. There is not an x, so your B is 0. C is your constant. which is negative 16. So I need to change my b to a 0 and my c to a negative 16 and calculate. And you will see that your zeros are at 4 and negative 4. So those are my x-intercepts. So negative 4, positive 4. Again, x squared is positive, which means I am opening up. This time, again, it wants to know greater than. So greater than is above the x-axis, which means my above the x-axis would be from negative infinity to negative 4. This one does not have the equal to bar, so that means negative 4 needs a parenthesis, and then in union with positive 4 to infinity. All right, next example. My terms are both on the same side, set equal to 0, so I can go ahead and choose my a, b, and c. You do want to be careful on this one because remember, a is what's in front of x squared, which is a negative 1. B is in front of x. Once again, there is no x, so your b is 0. C is your constant, which is positive 81. So I need to change my a to negative 1. My b is still 0. My c is 81. And calculate. So here I've got negative 9 and positive 9 as my zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So x-intercepts at negative 9 and positive 9. Now, this time, your x squared is negative, which means this parabola actually opens upside down. Now, it wants to know where it is less than or equal to 0. Remember, 0 is your x-axis, so below 0 are the intervals that it's talking about. So my first interval would come in from negative infinity until it got to negative 9. Since this problem does have that equal to bar, that negative 9 gets a bracket in union with my next interval starts at positive 9, and it gets a bracket. It's a bracket until it gets to positive infinity. All right, next example. Again, it's set ready for us with 0 on one side, so I can go ahead and choose my a, b, and c. My a is in front of x squared, so it'll be negative 1. My b is in front of the x, which means it's 2. My c is the constant, which is negative 1. So I'll put these in my quad calculator. So a is still negative 1. B is 2. C is negative 1. Now calculate. You'll notice that you just get one answer. That's fine. That just means that this quadratic function only has one x-intercept. It's at 1. My x squared is negative again, so this one opens down. So what that means is it just touches it at that positive 1 and goes the other way. That's how a parabola has just one x-intercept. This wants to know where's the graph below the x-axis or less than 0. Almost the whole thing. The only place that it's not below is at the 1. So it starts from negative infinity until it gets to 1. Don't include the 1 because there's no equal to in your inequality in union with 1 to positive infinity. All right, last example. I do need to move the 3x to the other side. So I'm going to subtract 3x from both sides. So now, and you'll notice that I'm going to put that minus 3x in between the other two terms because that's where it should go after the squared. So I've got x squared, then the minus 3x plus 17 is less than 0. So now it's ready to put in my a, b, and c. So a is 1, b is 17. Oh, excuse me, no it's not. B is negative 3. And C is 17. So A, I'm going to change to 1. B is negative 13. C is 17. You'll notice, oh, hang on. Oh, do you see what I did wrong? Which is why that gave me the wrong answer. My B should be negative 3. Sorry about that. So just go back and change it to negative 3. You'll notice that your answer has an I in it. You've got 3 plus or minus the square root of 59 I over 2. Where are you going to put that on the x-axis? You're not. And there's a reason for that. This parabola, when you graph it, actually has no x-intercepts, okay? Which just means it is going to be somewhere above the x-axis, but not ever come down and touch it. Which means if this is asking where this parabola is below 0, it's not, ever. There is no point on this graph that is below 0. So the answer to this one is called the null set. That means there is no interval that satisfies the question. So that null set symbol will be in your math lab toolbox.